We're Team 1 and we're going to present kinematics, dynamics, and static.
Kinematics is the branch of mechanics that describes the movement of solid objects without considering the causes, that means the forces that originate it, and is mainly limited to the study of the trajectory as a function of time. To do this, it uses velocities and accelerations, which describe how position changes as a function of time. Velocity is determined as a quotient between the displacement and the time used, while the acceleration is the quotient between the change in speed and the time used. The basic elements of kinematics are space, time, and an object. In classical mechanics, the existence of an absolute space is admitted, that is, a space prior to all material objects and independent of their existence. This space is the scene where all physical phenomena occurs, and it is assumed that all the laws of physics are rigorously observed in all regions of it.
The dynamics is a branch of physical science and subdivision of mechanics that is concerned with the motion of material objects in relation to the physical factors that affect them: force, mass, momentum, energy. This law states that the force acting on a body is equal to the rate of change of the body's momentum. Dynamic force is a force acting on an object that gets it to various zigzags, position, or direction. A force acting on an object becomes the load to the particular object. A good example of dynamic load is the weight of a moving car on the road. The foundation of dynamics were laid at the end of the 16th century by Galileo Galilei, who, by experimenting with a smooth bar rolling on an inclined plane, derived the law of motion for falling bodies. He was also the first to recognize that force is the cause of changes in the velocity of a body, a fact formulated by Isaac Newton in the 17th century, in his second law of motion. Newton's law of dynamics then indicates that the time derivative of the amount of the motion is equal to the sum of the forces acting on the system. The law of dynamics then indicates that these internal forces do not change the amount of movement of the global system A plus B.
The word static means lacking of movement. Therefore, static electricity is an electrical charge without movement. With this clear, a phenomenon of accumulation of an excess electrical charge that occurs when an electrical charge of certain atoms discompensates and stops being neutral, which is their usual state. In this way, the balance between components of the atoms, protons, electrons, and neutrons, will maintain a neutral change. For example, if we rub two objects together, an imbalance will occur, which leads us to have an exchange of electrons between the atoms. Those atoms will have a negative charge, while those that lose them will have a positive charge. It will be the moment when static electricity will be produced. The energy released in static electricity discharge may over a wide range. The energy used can be calculated from capacitance of the object of static potential in volts by the formula E1/2 CV squared.
In the experiment, the simulation of a block of 276 grams is made that is dropped after it is at rest on inclined surface without friction until it hits a 14 grams impact with a block B of 37 grams, that is a surface with UK equals to 0.42 centimeters. Until it comes to the rest, we will also determine the objects with units in centimeters.
Well, in this project we have two bodies as shown here. The car will be our object A, that is attached to a lace of a shoe in which distance is kept with the tape, that it is going to be the object B. To find the speed of the first object, that is the A1, the car, to find its speed before of the impact with B, we will use the conservation of energy in a surface without friction, like this. Now, to find the velocity of object B, After impact, we are going to use the Newton's second law. The car held it in a resting position, and when it's released, it causes an impact with the tape. So this tape, due to the impact reaction, makes it travel a certain distance until it stops due to friction. Right, like this. Um,
The first steps in order to find the coefficient of restitution is the conservation of energy on block A. We use its formula, and now that we have the formula, we search for the variables, the values of the variables, and now that we have the value, we substitute them, and we take the result just for the conservation of energy on block A, that it is 1.653. After doing the conservation of energy in block A, we search the second law of Newton's on object B. It is force equals to mass time acceleration. So we also search for its variables, and we conclude that the force will be 1.18. The third thing we're going to do is to look for the conservation of quantity of motion between the block A and the sphere. So that we first use the formula mass 1 times velocity 1 equals mass 2 times velocity 2. After finding it, we use this result that it gives us and we save it for later. Then we search for the other equation, and here we have our result for the third step.
Since the difference in speed in the sphere is minimal, it will be neglected as the speed of the sphere will be considered equal after the impact with object A and object B.
The fifth step is to find the conservation of quantity of linear motion between the sphere and the object B. So we use these two formulas, and we find its value. So we get this by doing substitution. The last step is four equations for non-incarnates. So we join all the equations and we solve it.
Solving the equations, we have that E equals 0.85, BE2 equals 2.33, BA2 equals 1.20, BE3 equals 0.80.